Imagine standing at the edge of everything. Not the edge of a city, not the edge of a continent, not even the edge of the world. The edge of the universe itself. Now imagine something is there. Something NASA wasn't fully prepared to find. Something that rewrote what we thought we knew about space, time, and our place in all of it. This is not science fiction. This is not speculation. This is what we actually discovered when we pointed our most powerful instruments into the deepest, darkest corners of the cosmos. And what came back changed everything. For most of human history, we looked up at the night sky and saw stars. Beautiful, mysterious, distant. But they felt close enough to name, close enough to dream about. Then we built better eyes, telescopes that could pierce through the darkness, satellites floating silently above our atmosphere, instruments so sensitive they could detect the faintest whisper of light from billions of years ago. And slowly, the universe began to reveal itself, not as a friendly neighborhood of stars, but as something almost terrifyingly vast. Here is the truth that took us centuries to fully accept. When you look deep into space, you are not just looking far away, you are looking back in time. The light reaching your eyes right now left its source thousands, millions, sometimes billions of years ago. The night sky is not a snapshot of now. It is a fossil record of the past. And NASA's greatest mission has been to read that record, to follow the light all the way back, as far as physics would allow, to find the edge. But what they found there was not an ending. It was something far stranger. In 1995, NASA made a decision that many scientists thought was borderline reckless. They pointed the Hubble Space Telescope, humanity's most expensive and precious eye in the sky, at a tiny, seemingly empty patch of darkness. A patch of sky so small it was roughly the size of a grain of sand held at arm's length. For 10 full days, Hubble stared into that void, collecting every single photon of light that passed through its lens, waiting, watching, patient in the way only machines can be. What came back stunned the entire scientific world. That tiny, empty-looking patch of darkness? It was not empty at all. It was filled, absolutely overflowing with galaxies. Nearly 3,000 of them, each one a universe unto itself, each one containing hundreds of billions of stars, each one separated from us by distances so vast that the numbers lose all meaning to the human mind. This image became known as the Hubble Deep Field, and it was just the beginning. NASA went deeper. The ultra deep field followed, then the extreme deep field. Each time, the answer was the same. More galaxies, more light, more ancient history pouring out of the darkness. Scientists now estimate there are somewhere between 1 and 2 trillion galaxies in the observable universe. Let that sink in. 2 trillion galaxies. And each one of those galaxies contains, on average, hundreds of billions of stars. The numbers are so large they stop feeling real. They start feeling almost like mythology. But they are not mythology. They are measurements. Cold, hard, verified, peer-reviewed measurements of the universe we actually live in. Now here is where it gets truly breathtaking. The light from the farthest galaxies Hubble captured had been traveling for over 13 billion years to reach us. These galaxies existed when the universe itself was barely a few 100 million years old, a cosmic infant. We were not just looking at distant space, we were looking at the earliest moments of existence. But even this was not the edge. Even this was not the final answer. Because beyond those ancient galaxies, beyond even the reach of Hubble, there was something else entirely. Something older, something stranger, something that NASA would need an entirely new kind of telescope to see. There is a wall at the edge of the observable universe. Not a physical wall made of rock or metal, but a wall of light. a boundary beyond which no telescope, no matter how powerful, has ever seen. Scientists call it the cosmic microwave background, and it is one of the most extraordinary things ever discovered in the history of science. Here is what it is. About 380,000 years after the Big Bang, which on a cosmic scale is practically the moment of birth, the universe cooled just enough for atoms to form. Before that moment, the universe was a dense, opaque fog of plasma. Light could not travel through it. The cosmos was essentially blind. But when atoms formed, the fog lifted. Light burst free for the very first time. It flooded across the universe in every direction at once. That light is still traveling, right now, in this very moment. After 13.8 billion years of expansion, that ancient light has been stretched by the growth of the universe, stretched so much that it has shifted out of visible light entirely, down into microwave frequencies that human eyes cannot see. But our instruments can. NASA's COBE satellite detected it in 1989. WMAP mapped it in extraordinary detail in the early 2000s, and the European Planck satellite gave us our sharpest picture yet. What does it look like? It looks like the universe breathing. Tiny fluctuations, ripples of slightly warmer and cooler regions spread across the entire sky. These ripples are the seeds, the original density variations that gravity slowly amplified over billions of years into the galaxies, clusters, and superclusters we see today. In those ripples, we can read the age of the universe, its geometry, its composition, its ultimate fate. And yet, here's what keeps cosmologists awake at night. This wall, this cosmic microwave background, is not the edge of the universe. It is only the edge of what we can see. Beyond it, the universe continues. How far? We do not know. It may be infinite. Some models suggest the true universe is so much larger than what we can observe that our entire observable universe, all 93 billion light years of it, is just a tiny bubble, a grain of sand on an infinite beach. Then, in 2021, NASA launched something that changed the conversation entirely: the James Webb Telescope. And what it showed us pushed the boundaries of human understanding to places we had never imagined. The James Webb Space Telescope cost $10 billion. It took 30 years to build. It folded up like an origami sculpture to fit inside its rocket, then unfolded itself in deep space with a precision that made engineers hold their breath for weeks. And when it finally opened its golden eye to the universe, it saw things that should not exist. Webb was designed to see further back in time than any instrument before it, to peer past the galaxies Hubble showed us and find the very first stars, the very first light. What it found instead was a puzzle that is still being debated. Galaxies, fully formed, massive, complex galaxies existing at a point in time when the universe was barely 300 to 500 million years old. That might not sound strange at first, but here's why it is. In order to our best models of how the universe works, galaxies take billions of years to form. Stars must be born, live, die. Their remnants must collapse and merge. Gravity must slowly pull matter together across vast distances. It is a slow, grinding, majestic process. Except, apparently, it wasn't always slow. Webb found galaxies that are far too big, far too mature, far too structured for their age. Some scientists called them impossible galaxies, not because they violated the laws of physics, but because they violated our understanding of how quickly the universe could organize itself. This is what happens at the frontier of science. The universe does not care about our models. It does not conform to our expectations. It simply is what it is, and it waits patiently for us to catch up. But Webb did not stop there. It detected the atmospheric signatures of distant exoplanets, worlds orbiting other stars hundreds of light years away. It found water vapor, carbon dioxide, the molecular fingerprints of chemistry that on Earth we associate with life. It did not find life, let's be clear about that. But it found the ingredients, the possibility, the haunting, undeniable suggestion that we may not be alone in a universe this vast. Webb also gave us something else, something more intimate. It gave us images of such extraordinary beauty that they stopped people in their tracks. Pillars of gas and dust, lit from within by newborn stars, galaxy clusters bending and distorting the light behind them, a phenomenon called gravitational lensing, turning the universe itself into a cosmic magnifying glass. Each image is not just a photograph, it is a dataset, a story written in light, a message sent across billions of years, finally received. And with each new image, the same feeling returns. That feeling of being very, very small, and somehow, inexplicably, incredibly lucky to be here at all. The edge of the universe, it turns out, is not a wall or a cliff or a final curtain. It is a mirror, and in it, we see ourselves, fragile, curious, reaching, reflected back across the entirety of time. So what did NASA find at the edge of the universe? It found that there is no edge. Not in the way we imagined, not a boundary you could cross, a border you could stand at and peer over into whatever comes next. The universe does not end. It expands. Always, in every direction, faster than light itself in the farthest reaches, carrying galaxies away from us so quickly they will one day vanish from our sky entirely. The observable universe, everything we can possibly ever see, is a sphere about 93 billion light-years across, and it is growing, not because new space is being added at the edges, but because space itself, the fabric of reality, is stretching, expanding, like a balloon being inflated where every point on the surface moves away from every other point simultaneously. There is no center, there is no edge, there is only the expanding now, reaching in every direction, carrying the light of 1 trillion galaxies with it. But here is the thing that stays with you, the thing that does not leave. In all of that immensity, in all those trillions of galaxies and quadrillions of stars, we have found one place where the universe woke up and looked at itself. Here. This pale blue dot, this tiny, fragile, breathtakingly beautiful world spinning through an unremarkable corner of a spiral galaxy that is itself just one of 2 trillion. We are made of the same atoms forged in the hearts of ancient stars. The iron in your blood was born in a stellar explosion billions of years before our sun existed. The carbon in your bones is stardust, literally. You are not separate from the universe. You are a piece of it that learned to wonder. NASA's greatest discovery, greater than any galaxy, any exoplanet, any cosmic structure, is the confirmation that in a universe of this scale, curiosity is not a luxury. It is the most profound thing there is. Because the universe has existed for 13.8 billion years without asking any questions about itself. Then life appeared. Then intelligence, then a species that looked up, built rockets and telescopes and satellites and sent them screaming into the dark, not because it was practical, but because we could not help ourselves. We had to know. We are still learning. There is still so much darkness beyond the light we've gathered, mysteries that Webb has raised more questions than it answered. Dark matter that we cannot see but know is there, invisible scaffolding holding the cosmic web together, dark energy accelerating the expansion of the universe in ways we still don't fully understand. The universe still holds its greatest secrets. But we are listening, we are watching, we are reaching. And somewhere out there, in the ancient light still traveling toward us from the edge of everything, the universe is still telling its story. We just have to be patient enough to hear it.